Good day, everyone. We are Group H from SSCE 2193 Engineering Statistics, Section 33. Our group consists of Chung Hui Qi A19EE0356, Loo Wei Yang Kon Ya Wen and Melanie Ivyn. Our group is in charge of monitoring the quality of tablet production for LajakKuruih Tablet H. LajakKuruih tablet is a health supplement diet tablet that manufactured by LajakLaku company. There are at least 15 types of LajakKuruih tablet produced by the company. 200 sample data observation taken at random from 3 production shifts, which are morning shift, evening shift, and night shift in December 2020. In Part A, we are required to describe and summarize the sample data of our assigned LajakLaku tablet produced in December 2020. Present the observations effectively in numerical, tabular, and graphical form. The first one is observations in numerical form. The table shows the overall numerical data analysis of 200 samples from production of LajakKuruih H tablet. We use Microsoft Excel to analyze the dataset and come out with total, maximum value, minimum value, range, first quarter, third quarter, interquarter range, median mean, variance, and standard deviation. We also do the data analysis for morning shift, evening shift, and also night shift. Second, observations in tabular form. We use frequency distribution to show the observations in tabular form. From this frequency distribution, we observe that the highest count of tablet weight is between 340 to 350 mg, while the least is between 300 to 310 mg. From this frequency distribution, we can see that the highest count of relative density of tablet is between 86 to 88%, while the least is between 94 to 96%. Next, from this frequency distribution, we observe that the highest count of tensile strength of tablet is between 7 to 7.2 MPa, while the least has 2, which are between 6.6 to 6.8 MPa and 7.6 to 7.8 MPa. Third, we have observation in graphical form. By using graphical method, we can compare the data among the 3 shifts, morning, evening, and also night shift. From the graph, it shows that the comparison of maximum value, minimum value, and average value of tablet weights among 3 shifts. The maximum value of tablet weight in evening shift is the highest, which is 382.79. The minimum value of tablet weight is during evening shift, which is 300.72. The highest average value of weights is during morning shift, and lowest average value of weights is during night shift. These two graphs illustrate the comparison for relative density and tensile strength between morning, evening, and night shift. The highest maximum value of relative density is during morning shift, while the lowest value of relative density is during evening shift. Same goes to tensile strength. The highest maximum value of tensile strength is during morning shift, while lowest value is during evening and morning. The graph shows the variance and standard deviation of weights of tablets produced. From the graph, we can see that the variance and standard deviation of tablet weight produced by evening shift is the highest, while by morning shift is the lowest. From the graph, it shows that the variance and standard deviation of relative density produced by night shift is highest, while by morning shift is lowest. And next, for this graph, the graph shows the variance and standard deviation of tensile strength produced by night shift is the highest, while by evening shift is the lowest. And that is all for Part A.
In Part B, we are required to give comment on whether there is a significant evidence that shows the weight of standard LajakLaku tablets produced in December 2020, regardless of the shifts, do follow the normal distribution with mean of 350 milligrams and standard deviation of 14 milligrams. Therefore, we implement the goodness of fit test in 4 different stages to test whether the weights of LajakLaku tablets follow the distribution. So first, we are doing for the hypothesis test, and we came up with 2 hypotheses where the H0 states that the weights of standard LajakLaku tablets produced follow the normal distribution, and for H1, the weight of standard LajakLaku tablets produced does not follow the normal distribution. Next up is the test statistic. We are executing the test with normal distribution with mean of 350 milligrams and standard deviation of 14 milligrams, total of 200 data at 5% significance level. In the table shown, we can see that the data are distributed into 9 different groups starting from 310 and ends at 380 with interval of 10. OI is the observed data, P is the probability of the normal distribution based on respective intervals, and EI is the expected data which can be obtained by multiplying the total number of data with respective probabilities. In this test, all values of expected data must be greater or equal to 5. Therefore, we have to merge the cells with values of EI smaller than 5. As we can see from the table, when the weight is smaller than 310 and when it is in between 310 and 320, both of the value of EI are smaller than 5. But we merge the first 3 cells instead of the first 2, as by merging the first 2 cells still results with EI smaller than 5. The same goes to the last cell, where it required to merge with the previous cell in order to achieve EI greater than 5. This is the new table where all the EI are greater than 5. Then we calculated the chi-square by using the formula OI minus EI square divided by EI, and we obtained the chi-square test by summing up all the value of chi-square of each respective groups, and the final value of chi-square test chi-square test is 5.7352. For decision rule, we first calculate for the value of the degree of freedom by using the formula V equal to K minus P minus 1, where K is the total number of groups and P is the number of estimated parameter. In this case, K is equal to 6, and since we are not estimating for any parameter, therefore P equal to 0, and the final value of V calculated is 5. With alpha equal to 0.05 and V equal to 5, the chi-square value obtained is 11.0705. And this is the graph that shows both the acceptance and rejection regions. From the graph, any number smaller than chi-square value, we will not reject the H0, while any number that beyond the chi-square value, we will reject H0. In our case, since the chi-square test value equal to 5.7352, that is smaller than 11.0705, therefore we failed to reject H0. With this, we can conclude that the weights of standard LajakLaku tablets produced follow the normal distribution with mean of 350 milligrams and standard deviation of 40 milligrams at 5% significance level. And that's all from me. Thank you.
Now I'm going to present about Part C to determine whether there is any significant difference between tablet weights from the different shifts. Firstly, we read the hypothesis statement where H0 is morning, evening, and night shift have the same population mean, mu1 equals mu2 and equals mu3, while H1 is for at least one of the shifts has different from each other. Here is a summary for each shift, and we can see that the average for them is almost similar. Therefore, we use the ANOVA single factor as a test statistic. And we build an ANOVA table here, where we calculate the variation between groups and within groups. From the value, we can calculate the F-test by using the formula mean of square between shifts divided by mean of square within shifts. And the answer we got is 0.7317. Next is the decision rule. H0 is rejected if the p-value is less than alpha, where alpha here is equal to 0.05. From here, you can see that the p-value is equal to 0.4842, which is greater than alpha. The p-value is then compared with alpha, while the f-test is compared with f-alpha. And the f-alpha here is equal to 0.3418. And in conclusion, since our p-value equals to 0.4842 is greater than alpha equals to 0.05, therefore we fail to reject H0. And it can be concluded that there is no significant difference between the tablets' weights from different ships. And the problem regarding fluctuation in tablet weights and inconsistent tablets' hardness is independent on the ship. In conclusion, all the workers in every ship do no mistakes on the tablets. Thank you.
Hey to all, now I'm going to present part D. Tablet's hardness can be represented by its relative density and tensile strength. Studies have indicated that its tensile strength depends on the relative density, regardless of the production shifts. Recently, a batch was found to produce a cluster of tablets that show low relative density values of 68%, 74.3%, and 80.1%. Based on the current data in December 2020, what is the predictions of the tensile strength for such tablets? Comment on the validity of the table that you have used to carry out this prediction. From here, we can see that the independent variable X is the relative density, and the dependent variable Y is the tensile strength. By using Excel, we can obtain regression statistic table, ANOVA table, and unknown regression coefficient table. First of all, from the regression statistic table, the observation is 200, which is the sample size of the data. This means that we do not miss any of the data. And from this table, multiple R is the correlation coefficient percent R, which is 0.8171. This indicates that there is a strong positive linear relationship between the relative density and tensile strength as R is close to 1. Next, this is the ANOVA table. And from the unknown regression coefficient table, we can obtain the least square estimates of alpha, which is 0.3552, and the least square estimates of beta, which is 0.767. And from these two values, we can get the fitted regression line expression as y equal to 0.0767x plus 0.3552. And this is the line fit graph plotted. The blue dot represents the tensile strength, and the red dot represents the predicted tensile strength. By using the fitted regression line expression that we obtained before, we can predict the tensile strength for the following relative density. This can be done by substituting the X as the relative density, and we can get the prediction of the tensile strength. The results are obtained as below. And thank you. I will pass the presentation to the next person.
For the linearity test, we use alpha equals to 0.05. The hypothesis statement is H0 equals to beta equals to 0 and H1 equals to beta not equals to 0. For the test statistic, we get the t-stat value from the table, which is 19.945. For the decision rule, we reject H0 if t-test is larger than 1.6526. Since t-test equals to 19.945, which is larger than 1.6526, hence we reject H0. For the conclusion, since t-test equals to 19.945 and t equals to 1.6526, which is larger than t, hence we reject H0. The data provided has a sufficient evidence to support the linearity between relative density and the tensile strength. For the homoscedasticity test, is to test the constant error variance of the model. From the graph plotted, the data was scattered along the red line. This means that the mean of the error is equal to 0 and the variance of the error is constant. The normality test is to test the error whether it is normally distributed. From the graph plotted, it shows the linear properties. Therefore, we can conclude that the data is distributed normally. The model is valid. Thank you.